In November 2012, NASA astronomers made a remarkable discovery, a new and distant galaxy named MACS 0647JD. Though smaller than the Milky Way, it was one of the most fascinating galaxies ever observed. Its existence was revealed only through a remarkable cosmic phenomenon called gravitational lensing. This occurs when light emitted by a distant object bends and warps as it passes through the gravitational field of a massive object between the source and the observer. In the case of MACS 0647JD, its light was magnified not by a single galaxy, but by an entire supercluster of galaxies. The Hubble and Spitzer telescopes captured this faint, stretched light, allowing astronomers to glimpse one of the farthest known galaxies, approximately 13.3 billion light-years away, at the very edge of the observable universe. Our universe, estimated to be just under 14 billion years old, contains light that has traveled nearly that long to reach us. This visible light forms the boundaries of what we call the observable universe. Even though the universe cannot expand faster than light itself, the region we can observe measures roughly 93 billion light-years across, far larger than what its age might suggest. This mystery lies at the heart of modern cosmology. Some galaxies, including MACS 0647JD, are now receding from us faster than the speed of light due to the expansion of space itself. The light we see from them today began its journey billions of years ago, but those galaxies have since moved beyond our cosmic horizon, forever out of reach. This raises profound questions. How can the universe expand faster than light? Why do distant galaxies accelerate away from us? The observable universe is only a portion of a much larger reality. Every point in space has its own observable universe, a region defined by how far light has traveled since the Big Bang. Beyond each region lies a cosmic event horizon, a boundary beyond which light has not yet reached. As the universe expands, galaxies cross this horizon, disappearing from view. According to current estimates, more than 96% of all galaxies we have ever detected have already moved beyond that horizon. The light we still receive from them is like a replay of their ancient past, showing us how the universe looked billions of years ago. By observing this ancient light, scientists can reconstruct the early history of the cosmos, seeing black holes forming quasars, young galaxies merging, and violent bursts of energy from newly born stars. The farthest light we can detect comes from about 46 billion light-years away, even though it began its journey only a few hundred million years after the Big Bang. The apparent contradiction between distance and time arises from the universe's dynamic expansion. Light from distant objects must travel through space that is itself stretching, so by the time it reaches us, those objects have moved much farther away. MACS 0647JD, therefore, appears both young and small because it formed soon after the Big Bang, and its light has been traveling across expanding space ever since. Scientists estimate that as the observable universe continues to grow, we may eventually detect as many as 2 trillion galaxies. However, there is an important distinction between what is observable and what is actually reachable. The reachable universe includes only the region within the cosmic horizon, those galaxies we could theoretically visit, given enough time. Beyond this, we can never travel or communicate, no matter how advanced we become. The expansion of the universe itself occurs at about 68 kilometers per second for every 3.26 million light-years of distance. This means that the farther away something is, the faster it appears to be moving away. Eventually, at vast distances, galaxies recede faster than the speed of light, not because they are moving through space, but because space itself is expanding. This does not violate relativity, since relativity governs local motion, not the stretching of space-time. In 1998, the High-Z supernova search team discovered that the expansion of the universe was accelerating rather than slowing down. This surprising revelation introduced the concept of dark energy, a mysterious force that seems to fill the vacuum of space and drive cosmic acceleration. Dark energy is not a form of matter but a property of empty space itself. It cannot be directly observed, yet its effects can be seen through gravitational lensing and the large-scale structure of the universe. Based on current models, dark energy makes up about 2/3 of all the energy in the universe, with dark matter accounting for another quarter, and normal matter, the kind that makes up stars, planets, and humans, comprising less than 5%. If dark energy continues to dominate, it could mean that the universe is far larger than the part we can see. Estimates vary widely. Some scientists suggest a finite universe roughly 78 billion light-years across, while others argue for a universe hundreds or even trillions of light-years wide. Measurements of spatial curvature from projects like the Sloan Digital Sky Survey and the Planck satellite indicate that our observable universe may be just a tiny fraction, perhaps only 1/4% of the total. This would imply a universe with a radius of more than 23 trillion light-years, possibly much more. Some physicists even believe the universe is infinite, with no edge at all, expanding endlessly in every direction. In the distant future, as expansion continues, galaxies will drift farther apart until most of them disappear beyond the cosmic horizon. Only the nearby galaxies of the local group, such as Andromeda and the Milky Way, will remain gravitationally bound together, eventually merging into a single massive elliptical galaxy nicknamed Milkdromeda. Billions of years from now, future civilizations in that galaxy will live in a cosmos devoid of visible neighbors. The night sky will no longer sparkle with distant galaxies, and they may never know that the universe once held trillions of them. It's humbling to realize that we exist at a rare moment in cosmic history, a time when the universe is still visible and rich with light from its distant corners. We can study its origins, witness galaxies near the edge of time, and contemplate mysteries like dark energy and cosmic expansion. Someday, those vistas will fade into darkness, leaving future observers alone in their island universe. For now, as we gaze at galaxies like MAX 0647 JD, we are peering not just into deep space, but into the ancient heart of creation itself, an echo from the dawn of everything we know, and a reminder of how much there is still to discover beyond the cosmic horizon.